Welcome to this discussion about solving linear and nonlinear inequalities. So we're going to begin this skill by focusing our attentions on how do we solve linear inequalities. And if you happen to be using the Blitzer text, either college algebra or the algebra and trig texts, you'll find this information in sections 1.7 and 3.6. So let's talk a little bit about solving inequalities. Um, the biggest thing that you need to remember when we're solving linear inequalities is you're going to focus on the same steps of isolating x as you would if you were solving an equation. Except that if you happen to multiply or divide by a negative value, you need to reverse the inequality symbol. So anything that was less than will then become greater than, and anything that is greater than will then become less than. And of course, that applies to the less than or equal to's and the greater than or equal to's as well. So let's walk through a few examples of solving linear inequalities. Okay, so here's a simple one right here. And if you were going to solve this equation, right, if this was an equal sign, what would you do first? Now, many of you would say, I would distribute this 3 through. And that's perfectly acceptable, and that's the way we're going to handle this. Okay, so let's go ahead and multiply that 3 through. So we have 3x plus 3 is less than 7. And then what would you do? You would get rid of this 3 that is being added by subtracting it on both sides, right? Okay, so that would end up being 3x is less than 4. And then last you would divide through by 3. And that 3 is positive, so there's no need to reverse anything. We're just going to divide through the left side and the right side by 3. And we would end up with the statement x is less than 4/3. And that just means that x can be any number less than 4/3. So 4/3, remember, is 4 divided by 3, which is a little more than 1 and 1/3. So where is that on the number line? It's between 1 and 2, but closer to 1. And then we want everything to the left of that value. And we're going to use that parenthetical end to indicate that we're not including that value. And then we would go ahead and write this as an interval. And remember, when we write intervals, we always write from left to right. So negative infinity all the way up to 4/3, but not including it. All right, next example, same thing. So why don't you try this one on your own? I'll wait while you pause the video and work through it, and then we'll come back and talk it through. Give it a shot. All right, welcome back. Let's walk through this one, and let's do it similar to the one we did before. Let's distribute through this -6, and we would get -6x minus 18 is less than or equal to 10. And then adding 18 to both sides would give us -6x is less than or equal to 28. Then we are going to divide through by that -6. And this is where that one key difference comes in. We want to make sure that we reverse the inequality symbol. And so we would end up with x is greater than or equal to -28/6, which simplifies to -14/3. So we want to find -14/3 on our number line. And so we would divide 14 by 3, and that's almost 5, right? It's 4 with some change. So it's almost -5, between -4 and -5. And it's everything greater than that value or equal to that value. So we're going to highlight everything to the right of that value, and we're going to include it. So we're going to use that bracket symbol. All right, and then we're going to also then show our answer as an interval. So -14/3 all the way to infinity. All right, here's a couple more examples. Same kind of thing. They're a little more complicated algebraically just because we've got some more things on the inequality, but it's the same idea. You would solve just as you would solve an equation, except for reversing the inequality if you multiply or divide by something that's negative. So for this first example, we have a 6x on one side and a 4x on the other side. So let's think about moving this 4x to the other side by subtracting it on both sides. And then if we move this x to the left, let's move this constant to the right. And we would end up with 2x is less than or equal to -1. And then when we divide out the 2, we would end up with x is less than or equal to -1/2. Find that on the number line. So -0.5 about right here. And it would be everything less than or equal to that value. So to the left of that. And we would use the bracket here because we are including the endpoint because of that equal sign as part of our inequality. So our final answer is -infinity to -1/2, including that endpoint. And then on this example, same idea. Let's go ahead and distribute this through. We would end up with 8x plus 8 plus 2 is greater than or equal to 9x plus 17. Now, again, we're going to want to bring everything to one side, and we're going to, you can do either way. You can take your x's to the right or your x's to the left. Inequalities are typically read with your variable to the left-hand side. So we're going to bring this 9x to the left. So if I subtract 9x on both sides, and then this is actually 10, right? So I can subtract 10 on both sides as well. I end up with -x is greater than or equal to 7. Now I want to get rid of that negative sign, so I'm going to divide this through by a -1, which means I'm going to need to flip or reverse that inequality symbol. So I'll end up with x is less than or equal to -7. So plot that -7 on the number line, and then it's going to be everything to the left of that, including the endpoint. So -infinity to -7 with that bracketed end.